Hello everyone, good morning. For today's lecture belongs to the kinematics of a particles. In the kinematics of the particles already we have seen, we are finding the field quantities like acceleration, the velocity and displacement of that particle, and what the relation existed between these three parameters of a moving particle we have to find out. So that's we are going to be seeing in this. In this connection, we are going to be trying to do one more problem, which is going to be consist of pulleys and the trolley, moving trolley, as well as one of the weight is going to be hanging to that system. So now I am going to be read out that problem. A trolley resting on a horizontal plane, right? The trolley is going to be rested on a horizontal plane, starts from a rest and is moved to a right with a constant acceleration of 0.18 meters per second square. So it starts from rest. It means that the velocity of the trolley at the initial stage is going to be 0, right? And similarly, it is moved to the right with a constant acceleration. That means AT is equal to 0.18 meter per second square. It is moving towards the right side. Determine the acceleration of the block B connected to the trolley. See, the trolley is going to be over here. It is connected to the rope and the pulleys, and we need to find out the AB is equal to how much, right? When a body is going to be start from the rest to 0, that means ut is equal to 0, and it has a constant acceleration, at is equal to 0.18 meters per second. We need to find out what is the acceleration of your block B. In the second case, the velocities of the trolley, the block after a time of 4 seconds, and the distance moved each of them. In this case, in the second case, what he has given, he has provided after the 4 seconds, we need to find out velocities of this one. BB is equal to how much, and similarly VT is equal to how much. This is going to be the second case when the time is equal to 4 seconds. After 4 seconds, we need to be found out. So now, how to develop the relationship between the velocity and as well as the acceleration? By using this figure, we are going to be identifying what is the variable length of the rope and where is the constant length of the rope we are going to be identifying. On that basis, we are going to be calculating the relationship between relationship of the displacement. There we can see the trolley is trying to move towards this side. That means this length, AB length, is going to be variable in this direction, right? Can you see the B trolley, that means the B pulley is going to be connected to the support. This is going to be constant, and similarly, can you see the D also going to be connected to the support is going to be the constant. These lengths are going to be the constant. So then BC, CD and the DE, suppose in this case what will happen? For this one, I am going to be taking over here to this distance. Can you see the distance of C and F is going to be always constant, and whatever I am going to be CFG, if I am going to be called GE also constant, because it's maintaining the length is going to be the constant. But which parameter is variable here? Can you see BC and the BC and the DG length is going to be variable, and that I am going to be considering here. That's going to be your XB, I am going to be calling, right? So these are the variable parameters. On this basis, we are going to be identifying the lengths of the variable parameters. Now I am going to be writing the equations in this case. That the distance between the AB, I am going to be saying that's going to be your XT. I am giving some notations over there. The distance of this length is going to be pulley to the trolley AB is going to be the XT, and between the B to C, C to D and D to Z, this length is going to be constantly it will move, that I am going to be say the XB. Now we have to write the equation for that. So now I am going to be writing that equation. So that equation is going to be XT length, that is the XT, plus, can you see BC, CD and DG is going to be constant. I am going to be taking these 3 3 into xb. These are the variable parameters. Plus we do have the distance of GE as well as the CF, that I am going to be saying GE is equal to L. So in this case, length of the rope is going to be constant, and xp plus 3xb plus GE is equal to L. Then what I am going to be doing, I am going to be deriving with respect to time, so that I will get the equation for that. So how we are going to be writing? dxp by dt, because with respect to the time, the length of this are going to be variable, plus 3 into dxb by dt equal to 0, because GE as well as the length is going to be the constant. So the same equation I am going to be writing Vt plus 3 Vb is equal to 0. If I am going to do the further simplification of this equation with respect to time, so that equation I am going to be getting d square xp by dt square plus 3 into d square xb by dt is equal to 0. Can you see? So in this equation we are going to be finding the acceleration relationship. So that's going to be, we are going to be getting, that's going to be a t square at plus 3 into ab is equal to 0. So this is the equation we have developed. So this equation at is equal to at plus 3 into ab is equal to 0. So now once I have got the relationship between the velocity as well as the acceleration, then I can substitute these parameters in this equation so that I can get the remaining parameters. There we can see the at is equal to 0.18 meters per second if I am going to be substituting in this equation, so that I can calculate the AB. So that AB is equal to minus of 8t by 3, then 0.18 by 3. So the finally from this equation AB is equal to, what is the value we are going to be getting? That's AB is equal to 0.06 meter per second square. Can you see? When the velocity, when the acceleration of the trolley is going to be 0.18 meter per second square, and your AB acceleration is equal to 0.06 meter per second square. So that I am going to be writing over here 0.06 meter per second square. So now in the second condition, we need to find out the velocity of your block B and the velocity of the trolley. We need to calculate it. So there we can see in the second condition, when the t is equal to 4 seconds, what is the Vt as well as the Vp. So in this case, what will happen? After the 4 seconds, what is the velocity of this? And we know the acceleration of this part as well as this part. At the same time, we know the trolley is going to be starting from the rest. It means that ut is equal to 0. And we do have at also 0.18 meters per second square is available. At the same time, the t is equal to 4 seconds available. So by using these parameters, we need to find out the velocity of this. That's going to be v is equal to u plus at equation. If I am going to be using the same parameter vt, ut, at, I am going to be getting. So then ut is equal to 0 and the t is equal to 4 seconds and at is equal to 0.18. Vt is equal to 0.18 into 4. So from this equation, if I am going to be simplifying, how much I am going to be getting here? That is around 0.72 meters per second I will get it. The same I am going to be writing here, that's going to be 0.72 meter per second I got it. Now we need to find out the Vb. If you want to find out the Vb, what is the equation we need to use? Can you see? By using this equation, I can find out the Vb. So from this equation, Vb is equal to minus of Vt by 3 I will get it. Already we know Vt is equal to 0.72 meter per second, 0.72 meter per second by 3. So then what is the value for this part? How much I am going to be getting for this part? So that is equal to 0. The Vb is equal to 0.24 meters per second I can get it. The same value I am going to be writing 0.24 meters per second. I can get it. Once if you are going to be calculating this value, we need to find out the distance of that part. So how to calculate the distance? How to calculate the distance value? So that the trolley, what is the distance it has traveled? Right? So from this equation, already we know that t is equal to 4 seconds. Alright? So that I am going to be using the distance traveled by the trolley is equal to ut plus half at square. Can you see? The t is going to be representing here is the time and the capital T representing the trolley. From this one, this parameter is going to be 0. Once it is going to be 0, then st is equal to half, at is equal to 0.18, t is equal to 4 square. So if you are going to be simplifying, what is the value of the st? So that st is equal to, that's going to be 1.44 meters. I got it. That means the trolley is going to be moving at a distance of 1.44 meters distance it has traveled. Right? So st is equal to 1.44 meters. If I am going to be substituting in this equation, so what I am going to be getting, that xb is equal to, so this value I am going to be writing over here. So in this equation, xt is equal to, already I got it, it's around 1.44 meters it has moved after a time of 4 seconds. xb is equal to, what is the formula? Minus xt by 3 I can get it. 1.44 by minus of 3. That means xb is equal to, what is the value for this part? That is equal to minus of 0.48 meters. I can get it. Can you see? xt is equal to 1.44 meters it has traveled towards the right. Similarly, the block B has shifted to the upward direction at the 0.48 meters. This minus is indicating the object is going to be moving in the opposite direction. I hope you are able to understand this problem, how to develop the variable lengths, how to identify the variable lengths, and how to subtract the remaining parameters. So on this basis, once you are going to be developing the displacement equation, then rest of the parameters are going to be easy to you. Thank you.